Now see this question. A condenser is used as a heat exchanger in a large steam power plant in which steam is condensed to liquid water. The condenser is a shell and tube heat exchanger which consists of one shell and 20,000 tubes. Water flows through each of the tube at a rate of 1 kg per second with an inlet temperature of 30 degrees Celsius. The steam in the condenser shell condenses at the rate of 430 kg per second at a temperature of 50 degrees Celsius. That means saturation temperature is 50 degrees Celsius. And also latent heat of vaporization is mentioned in the problem, that is 2.326 megajoule per kg, and the specific heat of the water is 4 kilojoule per kg Kelvin. So what is the effectiveness of the heat exchanger? This is the question. Okay, so the given data in this problem, the given data are one shell and 20,000 tubes, right? In a heat exchanger there is a one shell and 20,000 tubes, and the mass flow rate of the water from each tube is 1 kg per second. So if I ask you what is the total mass flow rate of the water, so total mass flow rate of the water is 20,000 kg per second. So let us consider that is a m dot c, right? C stands for the cooling fluid. Mass flow rate of the steam, right, that is m dot h, and that is a 430 kg per second. Cold fluid inlet temperature, that means water inlet temperature is mentioned 30 degrees Celsius, and the hot fluid inlet and exit temperature both are same because condensation of the steam occurs. So hot fluid inlet temperature and hot fluid exit temperature is equal to the saturation temperature, right, which is 50 degrees Celsius. Latent heat of vaporization, which is a HFG, that is 2.326 megajoule per kg, and the specific heat of the water is 4 kilojoule per kg Kelvin, right? And see, this is a problem, this is a problem of condenser type heat exchanger, right? And if I say condenser type of heat exchanger or evaporator type of heat exchanger, if there, then either you consider the problem as a parallel flow heat exchanger or counter flow heat exchanger. In both the case you are getting the same effectiveness, right? So let us consider parallel flow heat exchanger, right? Now see, this is the hot fluid inlet temperature, hot fluid exit temperature, and this temperature is equal to saturation temperature, and this is equal to 50 degrees Celsius, right? Cold fluid, this is a steam now, this is a steam, this is a steam, and this is water, this is water, right? Water inlet temperature is 30 degrees Celsius. So this temperature is 30 degrees Celsius. And in this question effectiveness is asked. So effectiveness we can write actual heat transfer to maximum rate of heat transfer, right? Actual heat transfer to maximum rate of heat transfer. And what is the actual heat transfer? So simply actual heat transfer we can write, this is the mass of steam which is condensate, that is m dot s, right? Mass of steam, that is condensate, m dot s, multiplied by latent heat of vaporization or latent heat of condensation, right? So this is the actual heat transfer. And what is the maximum rate of heat transfer? So to calculate the maximum rate of heat transfer, this is the minimum heat capacity rate multiplied by maximum temperature difference in a heat exchanger, which is a THI minus TCI, right? Now see, what is the minimum heat capacity rate? The minimum heat capacity rate is for the water, right? Because for the steam, that heat capacity rate is infinite because of the phase change, right? Phase change of the steam occurs. So maximum heat capacity rate is for the steam. So what is the minimum heat capacity rate? The minimum heat capacity rate is the heat capacity rate of the water, right? So simply we can write, this is a m dot s multiplied by HFG upon heat capacity rate of the water multiplied by maximum temperature difference in a heat exchanger. Now mass of steam which is condensate is given in the problem, that is 430 kg per second, 430 kg per second, right? Latent heat of vaporization, this is also given 2.326 into 10 to the power 6 joule per kg upon Mass flow rate of the water, that is 20,000 kg per second, 20,000 kg per second, multiplied by specific heat of the water, that is 4 into 10 to the power 3, multiplied by THI. THI is given 50 and TCI is given 30. So 50 minus 30. 50 minus 30. Right. So if you calculate this, then what you are getting, I already calculated. So this comes 0.625. 0.625. Right. So effectiveness of the heat exchanger is 0.625.